Hey, good morning. And we are going to begin in geometry talking about Euclidean geometry, just the introduction to Euclidean geometry. And I will just say that if you're watching this video is intended to support my class instruction, to support my class's assignments for the day. It may not be an all-inclusive on the topic and material, but it is to supplement what we're doing day to day in our classroom already with our curriculum. So as we talk about Euclidean geometry, Euclid, who lived around 330 BC, is considered the father of modern geometry. And from that point, a lot of things are still we still take as true, because his study of geometry was based in postulates, definitions, and theorems, or he used deductive reasoning, and which is making some observations and then being able to determine what the effects of those were, and in those we use these postulates, definitions, and theorems along the way. And postulates were a mathematical statement taken as true but not proven. So we accept certain things to be true, but we haven't been able to prove them yet. A definition is a formal statement declaring the meaning of a word, okay? And then third, theorem is a conditional statement containing a hypothesis and conclusion, and we're able to prove these, okay? So we have a hypothesis, question, and then we're able to make a conclusion. So with these, the difference, a lot of people get hung up here with the difference between a postulate and a theorem. And just understand that a postulate has not been proven, but we accept that it's true, and a theorem is something that we can prove. That's the big thing here. The foundational blocks of Euclidean geometry are started with three undefined notions, and these undefined notions consist of the point, the line, and the plane. So we have these three things that we will build the rest of our objects with. So we have a point, a line, and a plane. And our defined concepts in Euclidean geometry, however, these concepts are used they are undefined concepts, and they are used to define other foundational objects. So a point is a location. It's a location in space, and it has 0 dimensions, okay? So, and the point is a location on the coordinate plane designated by an ordered pair. And this should be familiar with, you should be familiar with this. This should be familiar to you from algebra, because we have a coordinate plane, right? And then we may have a point out there that's some xy coordinate, because that's what we were using in algebra in pre-algebra, when we started talking about the coordinate plane. And then we also have lines. And lines are a series of points extending indefinitely in two directions and have only one dimension, okay? It extends forever in two directions, has one dimension because it is not wide, it only has length, it has no width, and it has no beginning or ending, right? Because this is what my arrows mean as my line goes on forever and ever. So we have no beginning or ending. And then points on the same line are collinear. So if I have A, B, C all on those lines, A, B, and C then would be collinear. That's all that word means they are all on the same line. So looking at that, what we can do is we can turn around and we can say, this example, it says, use the diagram to the right to name the following. So as we can see here, just to look at it, we have 3 lines. Here I have this line, which could be considered, this could be line R, and there's other ways to name it, but when we name a line, right, we have a line would be named by, for example, this guy right here. We could say that that is line R, or we could also say that it is line NK. because we need to use 2 points on a line in order to name it. And then let's see here. So quickly we have this line, line P, we have line Q, and then we have a series of points here because my points are labeled with a capital letter. So for example, point H, right? Capital letter H is that location right there. So just doing some of that. Again, these are concepts that you've probably covered back in middle school, if not elementary school. But just as a reminder, what they look like. So, looking at 4 collinear points. If I look at this line only has 3 points on it. 1, 2, 3. Line Q here only has 1, 2, 3 points on it. So I can see here that line R has H, N, K, and I are all on the same line. So those 4 points are collinear. So H, N, K, and I are 4 collinear points. Then it asks me a line that contains point M. Okay, so here is point M. There's several lines. I could say, let's see here. I have line P contains point M. I could also say that line MN, right? Because this could be designated MN because both of these points on there. I could even say that that is line NO because that line extends forever in both directions and it goes through point O. So there's multiple ways to identify this, and I could also identify that as MO, line MO. And then, of course, since it goes forever and ever in both directions, it could be line OM or line ON or line MN. The order doesn't matter when it comes to that. And let's see here. See, it says a line that contains points H and K. Under the same premise, H and K, here we go, H is right here and K is right here. So again, I could say that that is line R. I could also say that it is line HK. It could also be line HN. You know, there's many different ways to label that as, identify that as a line. And see here, another name for line Q. Okay, so here is line Q. And I have 3 points on line Q. I have L, K, and J. I only need 2 to name that line. So I could say that would be line JK. Could also be line KL, or even line JL. So all of those would be acceptable line names for line Q. And then the intersection of lines P and R. The intersection of line P and R is going to be right here. So when 2 lines intersect, they intersect at a point. So those 2 lines are going to intersect at point N. So there you go. We are able to grab a couple of those examples and look at them with those first 2 of our undefined notions of the point and line. So let's see here. Let's go to the next page. And a plane consists of, well, I'm going to use some abbreviations here. How about infinite, right? Infinity. Infinite many lines and length and width. Okay, the plane consists of infinite many lines and has a length and width giving it 2 dimensions, okay? So you think about a piece of paper when you're drawing back in art class, 2D is that flat surface, and that's what a plane is. It's that flat surface. It has no beginning or ending, just like a line. So it does extend on forever and ever, but it just extends on forever and ever in all directions. So it has no beginning or ending. And the plane contains at least blank non-collinear points, 3 non-collinear points. So let's see, remember that coordinate plane that we talked about back in algebra? It extended on forever up and down and extended on forever left and right on my x-axis, and that was a coordinate plane. In order to label this, we could say that looking at this plane, it could be considered plane H, right? We have plane H, or we could identify it with 3 italicized letters, non-collinear. So we could say ACB, or I guess it would be better to say ABC. We could say ABD. So these would be okay to call that plane. We could not say plane ACD because they are all in a straight line. So that's why we couldn't do that. So that would not be a proper way to label a plane. Now, if 2 planes intersect, then their intersection is a line. So this image is intended to show 2 planes crossing, and they intersect at a line. Whereas if I were to have a line to intersect, I would say if I had a line come through, it would come through here. We'll call that point K, and then it would extend back there through there, and that would be intended to say that a line would intersect a plane at a point. So there you go. There's some intersection information and some nomenclature on how we would identify some stuff. And let's see here, looking at example number 2. Okay, so use the diagram to the right to name the following. We have 3 coplanar points, or I'm sorry, 3 coplanar points. Well, in this case, let's see here. How many planes appear on the figure? Let's skip down here. Technically, we're going to say that we have 4 planes on the figure. So I have each side of this pyramid that appears on this pyramid sitting on a plane. Each one of those sides could be considered a plane, but it's a limited size plane where we have plane R here, which extends on forever and ever in all directions. So just keep that in mind. So we could say technically there would be 5 planes. If we were to pick 3 coplanar points, I could say that VWX would be 3 coplanar points. I could even say that ZVY are 3 coplanar points. It just happens to be that plane right there. So there's different, I could also say that, how about X, Y, V? That is also indicating this flat plane right here. A plane containing point X. Well, I have plane R. That's one I have. I also have XWV, which is also the same plane. Another way to call it, I could say YVW. Again, we're looking for 3 non-coplanar points. In the intersection of plane R and plane ZVY. Okay, so ZVY is this plane right here, and it intersects plane R on this segment right there, which is going to be segment VY. And we're going to learn more about a segment later on, but and then how many planes contain point W? Point W, I have this plane right here, I have this plane right here, and then finally I have this plane down here. So we have three planes where W appears at. So there is some basic starting points for Euclidean geometry, talking about the point, line, and plane, talking about some of their basic characteristics, and that should be a good starting point for our assignment today. So again, this is just to complement today's instruction, to replace today's instruction if you weren't here in class, and I will try to fix those typos on the notes. Thank you.